Our special guest today is Dr. John Berger. Dr. Berger is an environmental science and policy specialist and a senior research fellow at the Pacific Institute. Dr. Berger is the author of Solving the Climate Crisis, Frontline Reports from the Race to Save the Earth, a book he spent more than 6 years researching as he traveled nation and abroad to gather a sweeping array of perspectives. A graduate of Stanford and the University of California, Dr. Berger has written more than 100 articles on climate change and transitioning to clean energy for such publications as Scientific American, the Los Angeles Times, and the Boston Globe. He has also been a consultant to the National Research Council of the National Academy of Sciences, corporations, utilities, and Congress. Dr. John Berger, welcome to Next Steps Forward.
Thank you very much for inviting me, Chris. I appreciate it.
It's a real pleasure and honor to have you with us. We've got a lot to talk about today, especially when it's been 75 degrees here in Connecticut the last week. So there's no such thing as climate change, but we'll get into that.
All right.
So, John, let's start by setting a benchmark for a conversation.
Sure.
People hear about global warming every day and may have a general idea of what it is and why it poses such a danger. But please share the details of what's happened over the past few centuries and what's happening now and what it all means.
Okay. Well, I'd like to make a suggestion, Chris, that we just take a moment to explain what climate change actually is, because I think that will help us understand what the changes are that have been occurring. So climate can be understood as long-range weather. That means long-term trends in temperature and precipitation over large geographic areas. And those determine the likelihood of our experiencing certain maximum, minimum, and average temperatures and precipitation and wind speed throughout the day and night and seasonally. So climate change is a change in this climate system, but it's an intricate system. And so it's a little hard for people to understand because it's comprised of the interactions of oceans and land and atmosphere and what's known as the cryosphere, or the frozen parts of the earth. And so these components of the climate system all interact with each other and with solar energy coming into the earth from the sun and then leaving the earth in the form of infrared radiation from everything on the earth. So that's how we get climate and temperature and precipitation. And when you change the amount of greenhouse gas in the atmosphere, which you do from burning fossil fuel, you thereby change the, let's say, the transparency of the atmosphere to heat, and you make it more like a blanket over the earth rather than, let's say, a mesh where heat can easily escape from the planet. So when you add more greenhouse gas to the atmosphere, it acts as a regulator, which leads to more water vapor being in the atmosphere. And water vapor is a powerful greenhouse gas. And so the CO2 and the water vapor together raise temperature. And the reason I say it's a regulator is because as you increase the temperature, you increase the amount of water vapor by about 7% for every degree centigrade. So there's more, in effect, heat blocking effect. So this is what climate really is, and it's affected long term by astronomical variations in the position of the Earth and the tilt of the Earth on its axis, the wobble of the Earth around that axis, and the shape of the Earth's orbit around the sun. And collectively, all of those astronomical cycles are called the Milankovitch cycles. And then there are other shorter term things like El Nino Southern Oscillation and North Atlantic Oscillation and the Indian Ocean Dipole. So you wanted to know what happens to climate over the centuries, and we're getting up to the present time. But over the centuries, Earth's climate has been relatively stable from the end of the Ice Ages, about 11,700 years ago, to the start of human civilization about, civilization began pretty much with the end of the Ice Age. But the climate has been pretty stable throughout that time until roughly the last 50 years. So what's happened in that time that caused the climate to change? So we're now experiencing very rapid and radical climate change because the Earth is warmer now than it's been at any other time in the past 125,000 years. And on the average, it's about 2.3 degrees Fahrenheit hotter than at any previous time. And not coincidentally, we have more heat blocking greenhouse gases in the atmosphere than at any time that we've ever had in the last 4 million years. Before we started industrializing and burning lots of coal and oil and natural gas, there were about 280 parts of CO2 per million parts of the atmosphere. Now we've increased that by about 50% just in our lifetime to over 400 parts per million. And we're seeing the Earth's temperature increasing at a rate that we haven't seen in many thousands of years. It's changing 10 times faster than the average rate of warming that we have seen over millennia. And we, as I mentioned, have more water vapor in the atmosphere, which has some very major impacts on the climate. It means that the rainfall events can be more severe, and sea surface temperatures also become, let me just say, as a result of greater moisture in the air, we have more downpours, more spates, and higher sea surface temperatures at the same time fuel more powerful hurricanes. So we have, as humans, raised the concentration of greenhouse gases, and those concentrations are increasing 250 times as fast as from natural sources that we know have occurred throughout millennia since the last ice age. So we're also seeing snow and ice cover diminishing. We're seeing sea levels rising and at an accelerating rate. And we see the oceans becoming more acidic. Soils are becoming hotter and drier, and their organic matter containing carbon, which is the basis for the greenhouse gas carbon dioxide, is oxidizing into the atmosphere faster. So soils that used to be a good sink to suck carbon out of the atmosphere are now reversing course and releasing carbon at a greater rate, causing more greenhouse gases. We're also seeing rivers and lakes and streams seasonally having less water and getting hotter, which is bad for cold water fish. And notably, although we've seen this average temperature of the Earth increase somewhat more than 2 degrees Fahrenheit, in the Arctic, we've seen temperatures increase 4 times the average, and on land, 1.5 times the average that we see over the entire planet, because the surface of the Earth is 71% covered by ocean water. So this is kind of like the context for how this is impacting human beings. And I'll just say one or two more things about like the science of what we know about the change in climate. We've seen that Greenland has lost 8.6 trillion cubic feet of ice since 1993. That's barely more than 30 years. And Antarctica has lost over 4.6 trillion cubic feet of polar ice. And so this is beginning to have a major effect on ocean circulation, which is very significant because ocean circulation takes heat from the tropics and it brings it to the northern latitudes. And conversely, it takes cool water from the polar regions and distributes it throughout the ocean to the tropics. So if we stop this circulation, then the tropics begin to overheat radically, and we begin to see extremely cold temperatures, previously long unknown, kind of like ice age temperatures happening in Northern Europe. So, what does this all mean in terms of human impacts, Chris? Um, the climate is really a wicked problem because it impacts every aspect of our lives and our livelihoods. It impacts our homes, our jobs, our food supply, our places of work, um, pretty much everything. And we're seeing people all around the world now facing multiple climate catastrophes, from things like extreme drought to extreme floods. Things that used to be floods that might have occurred once in 1,000 years or once in 500 years are now sometimes occurring once every 5 years. And we're seeing huge, unprecedented wildfires. All of these things are exceeding previous records in terms of scale and frequency. And this is creating really an existential crisis. It's not just an existential crisis for nature when you destroy ecosystems like forests, for example, or Arctic ecosystems that depend upon frozen ground and cold temperatures. But so what I'm saying is it's not just like you're taking a sledgehammer to delicate ecosystems and to natural resources systems, but we depend on these natural resource systems like agriculture and the oceans. And this climate change that I've been describing is like a multiplier of all the threats to ecosystems that are being presented already by expanding human populations and by development. It's also exacerbating national security threats and risks to infrastructure. For example, as sea level rises, we have trillions of dollars of property along the coasts. This includes pipelines, transmission lines, toxic waste dumps, landfills, industries, transportation links like rail lines and highways. And this is all at risk of flooding from sea level rise because, as I said, sea level rise is increasing rapidly, and we're seeing already we've had about 8 inches average sea level rise, but it's not uniform. In some areas, it's much greater, and the rate is increasing as well. So we are in a position where we're going to be seeing more frequent and extreme weather, more severe hurricanes, more raging wildfires, more severe droughts, more crop failures, higher food prices, higher property insurance costs, if we can even get insurance, and then this more torrential rains and worse air quality. So the impact will be that more people will be rendered homeless, and we're going to see more and more stress on our social safety net, which is already arguably fraying. But if we think it's bad now, when you have, let's say, 20 million global refugees, imagine what it will be like in 2050 or 2070 if we don't change course, because there are projections by reliable sources indicating that we'll have something like 200 million global refugees. And I will be glad to explain why that is, because there are some very clear reasons why that's going to happen. But I kind of gloss over the fact that we're also in the process of threatening millions of species with extinction. As we raise global temperature, we drastically increase the rate of extinction, which is already tremendous. And we've already seen that the abundance of wildlife is decreasing radically. It has the abundance of vertebrate species, for instance, has declined by 70% just in the last 50 years or so. And we're already experiencing these record high temperatures. And when I when I gathered some of this information that I'm relaying to you, back in July, for example, the world had its hottest day ever, and multiple U.S. states were under heat advisories. And in April and May, we saw parts of the United States with temperatures over 120 degrees and 127 degrees in India and Pakistan, and monkeys falling dead out of the trees in Central America because of the heat exhaustion. So the real existential crisis comes here as a result of this impact of extreme weather. Heat actually is the most lethal of the forms of extreme weather impacts. And by 2070, millions of our fellow Americans and 1 to 3 billion people elsewhere periodically will be exposed to unsurvivable combinations of extreme humid heat. And that means that you have high temperatures like 90 degrees, but you also have very high humidity. So the body cannot perspire and get rid of this heat. And the core temperature of the body begins to rise. And in 3 to 5 hours, you begin to experience organ failure unless you're able to get cool by some means. We already see thousands of people in the U.S. dying prematurely every year because of exposure to high heat. And this death toll from heat waves is rising. It was nearly 6,000 people a year between 1997 and 2006 in the United States. So this is a real serious problem. And we just can't continue making portions of the world uninhabitable and expect that we're going to be okay when we do that, because, like I said, this is going to affect significant portions of the southeast and southern United States as early as 2070. So I'm trying to be the canary in the coal mine here and calling attention to this, that we just cannot ignore this and pretend that this isn't happening or deny that it's happening. We're also going to be exposing an additional billion people on Earth to the spread of mosquito-borne diseases, because as we spread tropical conditions where there previously were temperate conditions, mosquitoes can then make their way to these temperate areas and threaten people. And we're already seeing globally, millions of acres in the Midwest flood in recent climate-related extreme events, and millions of acres of the American West subject to really prolonged drought and to very, very damaging, intense wildfires. So that's kind of the situation. And it's a long response to your question, but the question is really a very serious one that deserves serious and greater attention.
I mean, those statistics that you gave us in terms of the amount of trillions of cubic feet of ice lost in Greenland and Antarctica, you said that there are over 70 species, vertebrate species that are now extinct.
No, I said that 70% of the abundance.
70%, I'm sorry.
In other words, not that the species persists, but it's more rare and harder to find as a result.
So I live in Connecticut. We are at a level 2 drought. Drove upstate this weekend for a baseball tournament for my son, and I've never seen the reservoirs as low as they are. We have wildfires in Connecticut. In my 23 years living here, we've never experienced that. In your book, Solving the Climate Crisis, you call for a national climate plan. I mean, obviously, based on the scientific data, we need one. What would that look like?
Well, it would look like a very methodical set of scenario studies that would examine the different pathways to a clean energy economy using different combinations of solar energy, wind energy, geothermal power, hydropower, ocean power, and energy storage to provide for all of our energy needs in this country without having to rely on the burning of fossil fuel, which creates more greenhouse gas and which worsens the problem of climate change. So this is the path forward that we need to be following. Does that address your question?
Absolutely. And we just went through.
There's one other thing.
Sure.
That there's no like one size fit all formula in terms of a climate plan. It would be regionally adapted and would have regional input. But the idea is that this challenge is too important to leave to haphazard market forces and to allow a hit or miss approach to getting to a clean economy. We need the most cost effective, most efficient path to a clean energy economy that will save the public money and will save the government money and will reduce the deficit for reasons that we can get into perhaps later in the show. So this is it's an optimal path solution to the problem. It's trying to be rational about it and set quotas for how much greenhouse gas we allow to be emitted, and then to gradually constrict those quotas so that we begin to reduce the carbon that we're putting into the atmosphere and the methane and other greenhouse gases, and then reach a point where we zero out additions to the greenhouse gas burden of the atmosphere, and then subsequently begin actually drawing down that excess greenhouse gas. When we begin to reduce the level of greenhouse gas in the atmosphere, that's when global temperature can begin to sink, provided that by that time we haven't so disturbed global ecosystems like forests and soils that they begin to release more greenhouse gas than we are capable of compensating for. At that point, climate change goes out of human control, and then we will see temperatures inexorably rise, and we won't be able to do anything about it. And that will be basically a catastrophic civilization ending scenario that we want to do everything possible to forestall.
So we just had an election last week, and there were more than a few candidates and winners that are climate change deniers. Why do you think climate change denial persists, even with such overwhelming scientific data?
I think that it is really clear why it persists, Chris. And it persists because the fossil fuel industry has tremendous political and economic power and contributes huge amounts of money to lobbying efforts and to misleading advertising and misleading research. And politicians are basically subverted by this political and economic power. And in this country, there is no countervailing political and economic force that can stand up to this political and economic powerhouse, which is earning trillions of dollars a year from selling fossil fuels that we have to keep consuming, because once you burn the fossil fuel, you have to replace it in order to have heat and power the next minute. However, if you have fuel-free renewable technologies that use the sun and the wind and the heat of the earth, you don't have to keep buying fuel. So it's not so profitable for these companies, and that's why they're in the fossil fuel business and not primarily in the solar energy business or in the wind or geothermal business. The way to deal with this really is that we need to have a very powerful coalition of all the major interest groups that would stand to benefit in this country from having a renewable energy transition on an accelerated basis. And there are relatively few people in the fossil fuel industry. There's an ocean of other people out here in the labor movement, in the public health movement, in the environmental movement. Um, I think that the environmental movement hasn't spoken terribly effectively to the general public about climate change, and they tend to talk often in terms of narrow factional interests. There's one group that's concerned with saving the whales and another group that's concerned with protecting wildlife or conserving land or national parks. But this coalition, this disparate set of factions needs to coalesce and have a single coherent message to deliver to the American people, showing the relationship of climate change to commonly held values and to kitchen table issues like affordable food, like affordable home insurance, like affordable utility bills. Ultimately, we make the transition to an energy efficient, renewable energy economy, and our utility bills will fall ultimately. Our energy bills will fall because our economy will be more efficient, excuse me, and because electrical technology is inherently more efficient due to laws of thermodynamics than if you take a fuel and you burn it, and 2/3 of it roughly are lost as waste heat, and only 1/3 of the fuel is converted to useful electrical energy, for example, or to some other useful form, because energy is lost as it changes its state. So that's my thinking along those lines.
In your book, you state that in America, we're wasting between 30 and 50% of the energy used in buildings today. Is that possible to fix?
It is absolutely possible to fix. And it's not something that we're going to do overnight, but it's something that we really need to set goals for and make a point of doing on an accelerated basis. It's not as expensive to, as you might think, to retrofit a building. It's easier to build it correctly the first time, but if you have a building, the problems usually are correctable. For example, you can improve the insulation in a building, you can improve the leakage rate and seal around doors and windows, you can replace energy inefficient lighting, you can have energy efficient appliances. You can use a heat pump, which uses a lot less energy than a gas furnace. And by doing this kind of a national program, ultimately you would have to spend some hundreds of billions of dollars to retrofit the entire 110 building stock in the United States. But it would pay off like $1 trillion every decade because of the energy saved. So because this is something that will be a sound investment with a good return on investment, it makes sense for the money to be loaned by government and by the private sector. Now, the private sector has a short time horizon when it comes to investments, and they want to make money fast and get out. And investments in energy efficiency typically may take a longer period of time to pay off than some investors looking for a quick high return will find. Now, the answer to that is not for government to step in and absorb the entire cost of, let's say, retrofitting the building, but maybe stepping in and providing a low interest loan to the building owner, so the building owner can make the change necessary. This is true if you own your own home, let's say, and you just need some capital because you don't have the money sitting around to make this kind of discretionary investment. But if somebody lends it to you at a rate that is less than the value of the energy savings, you're going to ultimately be making money as you pay off that loan, and you're going to be putting money in the bank. So it sounds a little abstract, but it actually will be beneficial. Things are more complicated when a commercial building is owned by a landlord, but the utility bills are paid by the tenant. And here, there are systems available that could create financial flows of billions of dollars to retrofit the building sector. I talk about that in a chapter of my book, Solving the Climate Crisis, Frontline Reports from the Race to Save the Earth. It's a little complicated, and I really think it'd be better not to try to delve into all of the details, but it's something that's clearly laid out in the book, and it rests upon the idea of monetizing energy efficiency and treating energy efficiency as a resource equivalent to electricity coming into the building and so forth. So we can definitely retrofit buildings, and if we do that, we're going to be creating millions of jobs and a great deal of economic activity, plus major energy savings, plus savings of atmospheric discharges of greenhouse gases. So it is truly a win-win situation. You might wonder, Chris, if this is economically beneficial, why haven't people done this already? Why haven't corporations done this? And the answer is simply that it's in the nature of renewable technology that the fuel is free, but the cost comes upfront when you have to, let's say, build a wind turbine or a wind farm or a solar power plant, or put solar and a new inverter on your roof, or buy an electric vehicle. These are first costs that for many people are hurdles. So even though on a life cycle basis, you pay far less for an electric vehicle over 12 years than for a gasoline vehicle when you factor in all of the fuel costs and the maintenance costs, the operating costs. You still might buy the cheaper gas car if that's all you can afford at the moment. Even though, this is a special case, but electric vehicles are coming down in price, and they will be at parity, maybe even cheaper, because they're inherently simpler than gasoline vehicles with their hundreds of moving parts and multiple systems that you don't need in an electric vehicle. So we need, through policy, to provide financing to make it possible for renewable investments to be made, because, as I say, they will be profitable. They generate economic activity. They will generate tax revenue. They will pay for themselves several times over. This is probably the very most profitable investment we can make as a nation long term in this type of economic transition. We'll also increase our global competitiveness if we go all in on manufacturing solar and wind and geothermal power plants and energy efficiency technology, and manage to lower those costs. We'll be able to export them, and we'll create an economic stimulus in the U.S. and plenty of good paying jobs, as well as make the nation more competitive in terms of its own exports.
A few moments ago, you talked about, I'll call it the fractured coalitions in terms of save the whales and save the Amazon rainforest. Who should be spearleading this global coalition? Should it be the United Nations? And then the second part is, what responsibility does the U.S. have when it comes to solving the climate crisis?
Well, the United States is more responsible than any nation for having put legacy greenhouse gases into the atmosphere. And these gases, largely CO2, are very long-lived, and therefore having been responsible for most of the problem, even though today our emissions are only about 15% of the problem. We, as the wealthiest, most powerful economy on earth, have a greater responsibility than, let's say, Botswana to solve the climate crisis. And we need to be prepared to extend a helping hand to less developed nations and less prosperous nations, not just for humanitarian purposes, but because many of these areas, like Africa, are growing rapidly in population and will have growing energy needs. And as they grow, should they rely upon coal power plants and natural gas plants, that will further aggravate the climate crisis and make it even more difficult and intractable for developing nations to offset that type of increase in global warming impacts and global warming gases. So we have this historic responsibility. We have an ethical and a moral responsibility to help other nations leapfrog the fossil fuel age and go directly to clean energy technology. It will be more efficient and economical for them. They will save money. Their operating costs for their energy system will be lower if they make this transition as quickly as possible. But for the same reason that we haven't been able to pass policies in the United States that really facilitate a rapid clean energy transition here, because we've been blocked by the fossil fuel industry and their allies in their lobbying work. It's difficult in many other countries that are committed to fossil fuels because there are political interests through crony capitalism and oligarchy that make enormous amounts of money by perpetuating the fossil fuel industry. Unfortunately, major global banks are continuing to finance expansion of the fossil fuel industry. And if you look at reports that have been done by financial analysts of the banking industry, they reveal that just since the Paris climate talks of 2015, trillions of dollars have been provided by the major banks of the world, banks like Bank of America, Wells Fargo, JP Morgan, and they'll talk about their concern for the climate, while, with the other hand, providing investment capital in the form of loans to companies that are striving to expand their production of fossil fuels. So unless we regulate the banking industry and prevent this kind of financial flow continuing without restraint, we are going to see a continuation of a worsening of climate conditions. We have to somehow regulate the banking industry, raise the capital reserve requirements for risky investments in fossil fuels. And we know they're risky because they're inherently unsustainable. And these investments, being unsustainable, will at some point implode, because we cannot continue with fossil fuels. At some point, the world will begin to constrain the use of fossil fuels, and we already see there's an acceleration in the spread of new technologies, and most of the new generating capacity, the vast majority, is now renewable because it is cheaper to create a kilowatt with solar power and wind power than it is by building a coal power plant or a natural gas plant. It is much cheaper to use these renewable technologies, and it's cheaper on a life cycle basis, and utility economists are concerned about that.
As dire as this conversation is in terms of the state of the world, One thing you're optimistic about is something called regenerative agriculture. Please tell us what that is.
Well, regenerative agriculture is a very different agricultural model from the model that most American large farms are practicing today. It involves making the health of the soil the most central feature of your objectives. Rather than focusing on yield per se, the focus is on soil health, because soil health is more fundamental than yield. Ultimately, healthy soil will yield healthy crops, healthy livestock, healthy food, and healthy people who eat the healthy food. Now, what's going on here in regenerative agriculture? Let's take a look at the conventional factory farm model, where you douse the land with herbicides and with pesticides and with artificial fertilizers, and you expose the soil through plowing to forces of the sun and the wind. These are kind of expedient measures that give you higher yield as long as you keep putting in these expensive inputs, which in the case of artificial fertilizer is made from fossil fuel, from natural gas. So there are some vested interests, especially agribusiness suppliers, who want to continue selling these chemicals, herbicides and pesticides. The ultimate effect, though, is to kill off soil fungi and bacteria that are vital to a healthy soil ecosystem. The healthy soil ecosystem produces healthy plants, and healthy plants, through photosynthesis, increase their rate of absorption of atmospheric carbon dioxide, and through photosynthesis, the incorporation of that carbon dioxide into their own tissue, meaning their leaves, their stems, and their roots. Particularly, the roots are especially important because as the roots decay, they become part of the soil complex. And the presence of fungi interacts. There are fungi called mycorrhizal fungi, which create little channels or tunnels that pass nutrients back and forth from plant roots to the soil and take away waste. And this causes the plant to be more capable of absorbing atmospheric nitrogen. So instead of having to put artificial nitrogen fertilizer into the soil, the healthy soil ecosystem sucks nitrogen that it needs out of the atmosphere and enriches the soil that way. So the soil carbon is like the energy fuel for the soil ecosystem. And the more the plants take carbon dioxide out of the atmosphere and put it into the soil, the darker the soil becomes in color, and the richer it is, and the more capable it is of holding water and growing healthy plants and animals. So it's also cheaper for the farmer long term to rely on, let's say, a mixed regime of growing cover crops and then having livestock graze that. Let's say a herd of sheep come and graze that cover crop off. Some of the cover crop enriches the soil, let's say clover, which is a nitrogenous crop, and then the animal manure provides natural fertilizer. So this is kind of like replicating the natural prairie ecosystem that existed before farmers came along, and when the buffalo roamed, then their hoofs did a little bit of soil tillage, and their fertilizer created, along with the grasses, created a healthy and deep, rich, prime agricultural soil. So,
Dr. Berger, we have just a few minutes left. Can you take us into our conversation with your perspective on why we should have hope in the face of climate change?
I think that we should have hope because we have a very, very strong case here. And we outnumber the bastards, basically. we
Is that scientific speak?
But we need to get our act together, and we need to do better organizing. We need to work with other people. We need to do less navel gazing and worrying about our climate angst, which any reasonable person would have. But we have to go beyond that and realize that if we work alone, we're just like a drop of water. But if we work together with others, we're like an ocean. And the case is very clear, and it's really beneficial to this country in economic terms to clean up each economic sector: the transportation sector, the industrial sector, the commercial sector, the residential sector, and the agricultural sector. We know how to do this. We have all of the technology we need. We just need to scale it up rapidly, and we need to talk to people to help them to make the connections between human health, environmental health, economic health, and a clean, healthy, renewable energy system. I bring in health because I already talked about the risk that mosquitoes present rather. And then there are other risks to health from fossil fuel induced air pollution, which globally kills at least 10 million people a year and sickens hundreds of millions of other people. And if you want to put a dollar value on it, Chris, I mean, that's trillions of dollars if you value a human life at any reasonable rate. But we're also in this country spending $1 trillion a year, $1.2 trillion to be more exact, buying and burning fossil fuel. It's just like we're lighting money on fire. And instead, we ought to be investing that money in a new clean energy infrastructure. We have in this country 3 multi-billionaires who have as much money as the bottom 50% of the American people, and the top 1% of the wealthiest people own as much money, as much wealth, I should say, as 80% of the rest of the public. Why not have a wealth tax on the super wealthy? 2% of our $27 trillion worth of collective wealth that's held largely in the hands of these super rich people would provide $500 billion a year, which could be used to have a very speedy and elegant and economically profitable energy transition. And dollars invested in this kind of a transition would pay off 4 times the initial investment in terms of the energy savings and all the other benefits, plus the avoided costs of an aggravated climate crisis.
Dr. Berger, author of Solving the Climate Crisis, Frontline Reports from the Race to Save the Earth. Thank you so much for being with us today. It was a real pleasure and honor, and we have to have you back because there's a lot more to get into here.
Okay. Thank you very much, Chris. And people who want to find out more about this can go to johnjberger.com or to solvingtheclimatecrisis.com. And all of the details are spelled out in my book, Solving the Climate Crisis. And it's published by 7 Stories Press.
Terrific. I'm Chris Meek. We're out of time. We'll see you next week. Same time, same place. Until then, stay safe and keep taking your next steps forward.